Okay, what if I told you that a book written over 1400 years ago had a secret mathematical key hidden inside it? Like a divine watermark, right? Something put there to prove where it came from. I know, it sounds like something straight out of a movie, but this is the actual claim of a new scientific paper that's using some really advanced statistics to analyze the Quran. So, really, this is the big question we're tackling today. Could a book actually contain a hidden mathematical proof of its own origin? I mean, think about that for a second. It's this wild meeting point of faith, math, and modern data science. It's a huge, almost unbelievable claim for sure. All right, so in this explainer, we're going to dive deep into that very paper. It uses this really powerful statistical tool called Bayesian analysis. Now, don't worry, all you need to know is that it's a way to measure evidence and see how it should change your beliefs. The goal here isn't just to point out some fun number facts. No, the paper is trying to calculate the actual mathematical odds, the probability that the Quran is divine, not man-made. So let's jump right in. Okay, so the paper organizes its evidence into these different codes. First up is code 7. Now, if you know anything about Islamic tradition, you know the number 7 is a big deal, right? You've got the 7 heavens, the 7 trips around the Kaaba, it's everywhere. But the question this analysis asks is that just a theme, or is it actually baked into the very structure of the text? And they look for two kinds of patterns here. Basically, they're counting how many times certain important words show up. And then they're looking at the big picture, the structure of the book itself, to see if it's built around the number 7. So the first piece of evidence they put on the table is this number, 70. So what's so special about 70? Well, according to the paper, that is the exact number of times the phrase Day of Judgment appears in the Quran. And here's the key. It's not just a random number. It's a perfect multiple of 7, 7 times 10. All right, next up, the paper brings up the number 77. And this is how many times the word for hell shows up. But, and this is where it gets interesting, the authors say this isn't just one clue, it's two. See, 77 isn't just a multiple of 7. It's specifically 7 times 11. They argue this is a deliberate link to a whole other code, which we're going to get to in just a minute. Okay, so we've seen word counts. Now the analysis zooms out to look at the entire book. Get this. The claim is that if you take the total number of chapters, which is 114, and you tack on the number of verses, 6236, you get this huge number, 1,146,236. And that number, it's perfectly divisible by 7. But wait, here's the real kicker. If you flip that number around backwards, it's still divisible by 7. The paper calls this a palindromic divisibility, and they figure the odds of that happening just by chance are about 1 in 49. So that gives you a taste of code 7. Now, the paper moves on to a totally separate set of patterns. This time, everything revolves around the number 11 and how it connects specifically to the Prophet Muhammad himself. And the argument here is pretty layered. They pull together evidence from 3 different places. Key facts from the Prophet's biography, the structure of the one chapter that's actually named after him, and even the numerical value of his name. So first, let's look at his life story. The paper points out what it calls 2 numerical bookmarks that just happen to be the number 11. He passed away in the year 11 of the Islamic calendar, and over his lifetime, he had 11 wives, a number the paper points out is pretty unusual and, well, happens to match the code. Now check this out. We're zooming in on the one chapter in the entire Quran named Muhammad. That's chapter 47. Okay, add the digits. 4 plus 7, that equals 11. Now, that chapter has 38 verses. Add those digits. 3 plus 8, that also equals 11. The paper calls this a dual signature, like a double confirmation, right there on the chapter with his name on it. So, okay, we've seen these claims about code 7 and code 11. They're interesting, right? But how do you go from interesting patterns to a mathematical proof? Well, this is where the paper brings out the big guns, the statistics. The main tool they use is something called a Bayes factor. All you really need to know is it's like a score for how strong a piece of evidence is. So a Bayes factor of, say, 100 means the evidence makes your theory 100 times more likely to be true. It's simple. The bigger the number, the stronger the evidence. Now, the analysis doesn't just look at codes 7 and 11. It also pulls in research on another really well-known system called code 19. And when they calculate the Bayes factor, that evidence score, for each of these codes, the numbers just get huge. For code 7, the evidence is rated at about 10,000 to 1. For code 11, it's 100,000 to 1. But for code 19, Brace yourself. It's 10 to the power of 21. That's a 1 with 21 zeros after it. Just an insane number. So what do you do with all that? Well, here's the crucial step. The paper argues that these three codes, 7, 11, and 19, are all statistically independent. That means you can multiply their strength together. So you take the absolutely massive number from code 19, and you multiply it by the strength of code 7, and then multiply that by the strength of code 11. And the final number they get from all of that multiplication is 10 to the power of 30. That is a 1 followed by 30 zeros. I mean, how do you even wrap your head around a number that big? The paper gives this great analogy. Imagine you flip a regular coin, and it comes up heads. You flip it again, heads again. You flip it 100 times, and it comes up heads every single time. At some point, you're not going to think you're lucky, right? You're going to think that coin is rigged. Well, the paper is basically saying the same thing is true for this text. So what does a number like 10 to the 30 even mean in the real world? This brings us to the paper's final and, honestly, most startling conclusion. The argument, essentially, is that evidence this powerful just overwhelms skepticism. This table from the paper shows it really clearly. Let's say you start out as a huge skeptic. I mean, you think the chances of divine origin are literally 1 in a million. The paper argues that the sheer mathematical weight of this evidence is so strong it would force your belief up to 99.99% certainty. But wait a minute, right? There's an obvious counter-argument here. Isn't this just cherry-picking? You know, if you look hard enough for patterns, you'll find them anywhere. The paper actually brings this up, and their response is that these patterns aren't just random. They're all clustered around numbers that are already deeply important in the faith, 7, 11, and 19. And that, they argue, is the smoking gun for intentional design. So when you boil it all down, the paper's final verdict is this. This whole interlocking system of mathematical codes is just too complex for any human to have created, especially an author in the 7th century who didn't have a computer. They also make a point of saying that when they've run similar analyses on other religious texts, they don't find anything like this. So the conclusion is that these patterns act as a kind of unique, unforgeable authentication code. And that leaves us with one last really big question, doesn't it? By putting all of this in the language of hard numbers, of probability and statistics, this paper is really pushing us to think about an old question in a totally new way. Where exactly does the math end, and where does faith begin?